I'm going to talk about serverless application architecture, just like Ron mentioned. First, in 20 minutes, you will have learned these two things. You will have learned a quick method for designing a good UI as a group. I know this is not strictly serverless, but I found this an amazing experience when we did it in a team where we built an application here within Google. You will also learn how to design a serverless app on Google Cloud and some of the travails, the design decisions we went through when we built. I find myself that it's easier to learn about these things in context rather than rather than just me telling you that Google's products are great. So first off, this is what I look like when I wear a denim jacket. I was born and raised in Sweden, lived in Silicon Valley for a long time, done IT consulting and a bunch of startups. I worked at Google here for a long time. I'm a cloud developer advocate. So my job is to help you do cooler things in cloud, reach further, stand on the shoulders of Google when you build your startup or your enterprise. If you wonder anything else about serverless on Google, you should totally check out Serverless Expeditions. This is my video series. We have over 100 episodes out now. Either click that link or just do a search for Serverless Expeditions on YouTube and you will find them. So we try to cover all the common use cases there, the different applications you might want to build and how you might want to build them serverlessly. All right, so the application we're talking about here, we have one example that will run through the entire presentation, and that is we needed a tool. We are the users out there on the right, Sarah, Wes, me, a bunch of other things who were creating videos, and all these people, viewers, are creating comments. So we needed all those to be to see all those in a nice report, so we could respond to viewer feedback and questions. So an enterprise application you might build or startup you might build might not look so different from this. You have data coming in, you need to do something, you have data coming out of your system. Let's see how we build that serverlessly. But first, Sarah, my coworker, introduced me to this double diamond process. So basically what you do is you do some research, you discover things, then you refine it, get your problem definition there in the middle. Then you sort of expand it out and you develop and think about design, and then you listen and hone in on a particular design, and then you have the solution on the far right. So let's see how we used that here. So here are the use cases. I need to know when there are new comments. I need to mark comments as read so I could get back to them or remember that I need to get back to them. So we started out here on the left with creating creating the use cases, and then we got to this mob user interface process, and this is really cool. This is one of the things I want to tell you about here. If you don't have a UI team, many startups don't, or you work with your UI team, you can work through this process. Everybody draws the UI for 5 minutes, then you compare drawings for 10 minutes and circulate them in the team and look at them, talk about them. Then everybody draws another time. But now you must include one item from each other person. You repeat this 3 times, boom, you have a pretty good design that you can go with. This will mean like in 2 hours, 3 hours, you will have a pretty good design so you can start building your prototype or even your application. I wish I had known this when I worked back in startups before I joined Google. So we drew like, okay, how do we want to see these videos? We were 4 of us, we drew them here. As you can see, our pictures were quite different. Second iteration, we started getting slightly more similar, even more similar. And finally, we arrived at something that we could create a mock-up of. And that was in the less than an afternoon it took to get to a pretty good mock-up of what this YouTube comment tracker should look like. I encourage you to follow this process in your design sprints, in your startups or enterprises. All right, so that was that. And I'm going pretty fast because I want to make sure we're respectful of time here. But here are the use cases. We now have a UI that addresses these use cases. Now it's time to build the application on Google Serverless because this is an application I'm not an expert in Linux server maintenance. We wanted this to be an application we could deploy and sort of not have to do maintenance on. I have a day job, which is to shoot videos and to talk to developers and build code and so on. I don't have time to do maintenance of a bunch of internal tools here at Google. So yep, just to repeat, here's what's going on. All right, so my coworker drew this picture. He said, look, Martin, we have the YouTube API, that's our input source. Then we have an output over there, that's the web browser, and we have the users over there on the far right. Now, something needs to go in between these to sort of transform the input data to useful output data. And when you think about it, a lot of systems are just like that. Even if you don't build a YouTube comment app. So what goes in the middle? Well, maybe nothing. Web browsers are amazingly capable these days. What if we just wrote a React app or Angular app or a Vue app or a Svelte app out there on the far right? Web browsers can do so much today. But then we returned to our use cases and we saw that we need to mark some comments as read so we can ignore them, or we need to keep them open while maybe I'll go and ask somebody about the answer to this question. So it can't be straight up. We need some local storage. But web browsers do that too. Could this be just a web application? That would be amazing. No cloud component, no worries. We just need to serve up the HTML. Well, then we realized that if a user goes in on their phone versus they go in on their laptop versus their desktop computer versus a Chromebook they might have, the storage would all be different. Which comments are marked as read would be different. You would want that memory in the cloud of this particular comment that came in from Bob yesterday. I need to address it. You would need that to follow you across devices. So we need some stuff in the cloud. Some sort of data storage there. All right, we need data storage. Now, what data storage? We want it to be serverless, and we want it to be easy to whip up a quick proof of concept of this application. So, of course, you know this, that the big question is SQL or NoSQL, relational or non-relational. And we decided to go, I'll go back here, NoSQL, non-relational, we find is easier to get started with, easier to just whip up something real quick. SQL is great if you have more like enterprise data, or if you need to do lots of aggregations on data, or if you handle money, we need to sum up things. NoSQL could be a lot better for this sort of use case where you just need to find a user and that user's data. So the preferred one in the database for this is completely serverless in Google. It's called Firestore. It exists in two flavors. There's a page that describes which one you should pick. It turns out that it's in native mode or data store mode. It turns out either one was good for us, actually. But if you have very special use cases like you're writing a mobile app, you might want the native mode, because Firestore in native mode means that your mobile app can read directly from the database. You don't need to write that layer in between. You don't need server-side code. It's pretty amazing. So we went with Firestore in native mode. Great to connect to the web browser. And we could, yeah, as this picture shows, we could actually have the web browser read natively from Firestore. Just client-side JavaScript, read from the database. No server-side code. Great. Less code is better. However, we did discover, as we looked close at the problem, that we'll get large data sets, a lot of data from YouTube. But we'll just show a little data to the users. Like we might get from, there are 100 videos in Serverless Expeditions video series. We would get 100 videos, the records for them, and thousands of comments. But in the report, we might only want to show Sarah, for example, like, hey, Mary posted a comment last Tuesday, and you need to respond to that. So because we have large data, small data, it would be helpful to have something in there in between that sort of shrunk the large data into small data and figured out what the user is most interested in. All right, so we do need some server-side logic after all. It would be nice if you can do without it. Code, as you all know, code is a liability. we don't write code because it's fun. We write code to solve a business problem, and we want to write as little as possible of it because it takes maintenance. There are bugs. As little as possible. Okay, we need server-side logic. What should it go in? Okay, serverless, we wanted that. We know that. We have a serverless database, Firestore, that it just expands and shrinks and grows as needed. We pay exactly only for what we use. App Engine, Cloud Functions, or Cloud Run. These are the three serverless products in Google Cloud. Now, I'll go back to that. So App Engine and Cloud Functions, great products, great if you want to whip up something quick. Cloud Run we find is useful for if you have a larger application with a rich REST API, for example, that we discovered our application would need. Also, Cloud Run is really good if you like containers. Now, I didn't even know anything about containers 2 years ago, but I studied up on them, and containers are pretty amazing because you put your application code and all its dependencies in a container. So your code, you won't have any more of that. Oh, it works on my machine. You deploy a container. So we decided to go with Cloud Run because life is good with containers. All right, great. So we have Cloud Run, we have Firestore in native mode. This is starting to look good. We do need something more. We do need to figure out, should we generate the HTML on the server or on the client? We figured that we would probably need a very responsive client. So if you click on something like, okay, I read Mary's comment, we don't want to have a round trip to the server, generate new HTML, come back. We could just handle that in the web browser. So, and then just talk JSON with the server. So we decided to go for a dynamic web application. In our case, so we could go with any of these frameworks or any other. On the team, we had Vue skills, so we picked Vue. But any of these would work, or any. There's a new JavaScript framework every week. They all work with Google Cloud. All right, web browser, Vue.js, excellent. This is starting to come together. It's starting to look good. We needed lots of REST endpoints. So for all these REST endpoints, they are all in the context of a user. Like, I'm Martin, I come to the application, get me my playlists. So we needed to know who the user was. We needed some sort of authentication. There are 3 ways of doing this on Google. Google Sign-In, Firebase Authentication, Cloud Identity Platform. Firebase Authentication and Cloud Identity Platform, they're really cool in that they support more than just Google identities. Google Sign-In, only Google identities. It's in the name. Firebase Authentication, you can sign in with you can have users sign in with your Twitter or your Facebook account, your Microsoft account, and so on. Then Cloud Identity Platform gives an additional layer of sort of enterprise-y features like force multi-factor authentication or multi-tenancy and so on. So we ended up going with Cloud Identity Platform. So then users can log in, they can use their non-Google accounts or their Google accounts, or they can create a brand new account, email and password. But it's all taken care of by Google, because honestly, I've been in startups. I don't want to write yet another login system and storing passwords and salt and all that stuff you do. Let somebody else do that. Plus, our users don't want to have to remember yet another password. Static web hosting. Where would we put the HTML and JavaScript files? We could put it in Cloud Run inside the container, or we could put it in Firebase Hosting. Firebase Hosting, I really like that because it includes a CDN, worldwide CDN. So users from wherever in the world will get your static files very quickly if you put on Firebase Hosting. And you don't have to do anything. You just write one command to deploy to the CDN. However, I was overruled on that because others said, no, let's package everything inside one container. And that is actually quite nice because now we have the server-side assets, we have the server-side code, client-side code, everything is in one single container. And I actually had last week, I ran into position where this was very useful because we had deployed a bad version of this container, but I could just, with 2 clicks, I could roll back to the previous container version of the container that we knew was good. And boom, we'd roll back server-side code and client-side code. So that was our final application. And that is, and here I am, momander@google.com. Please hit me up. Feel free to shoot me an email if you have any questions about Google Cloud Platform, and especially if you have questions about serverless. Also, do check out Serverless Expeditions. Thank you for your attention.